This mineral is in fact rhodonite, which I say largely because I asked people to identify this mineral yesterday, so well done to everyone that said rhodonite. Now, this is a mineral that manages to be both academically interesting and, on occasion, actually really pretty. It's a manganese silicate, and the formula is thus, although this is the elongated formula as it's usually simplified to MnSiO3. This is the simpler version, largely because manganese is generally the dominant cation. Now, rhodonite forms in manganese metamorphic environments. So the gist of this is you start with manganese-bearing sediments like manganese carbonates or oxides, and then during regional or contact metamorphism, which is where the rocks get heated and squeezed basically, these manganese sources react with silica to crystallize what ultimately turns out to be rhodonite. This process usually takes place in the medium grade metamorphic zones. So this is roughly 400 to 600 degrees Celsius, which is hot enough to actually recrystallize the rock, but not so extreme that everything just melts or gets completely obliterated. So you can find rhodonite in hydrothermal veins where hot fluids carry that manganese and silica into cracks, crystallizing the mineral as that fluid ultimately cools. And in terms of morphologies, this is quite diverse. You can get massive granular aggregates, bladed crystals, tabular crystals, fibrous intergrowths. In terms of shape and habit and diversity and morphology, there are loads of different iterations of this. So when fresh rhodonite is that sort of very distinctive rose pink, hence the name from the Greek rhodon equaling rose, exposure to air or alteration has often darkened it to a brownish or black due to surface oxidation into manganese oxides. Now, the localities for this are quite variegated. Broken Hill, Australia, Langban, Sweden, Franklin and Sterling Hill, New Jersey, Russia, generally areas around the Ural Mountains, Peru, Brazil, Japan, even places like British Columbia in Canada. Now, if rhodonite is going to be confused with anything, it's most often things like rhodochrosite, which is a manganese carbonate, as opposed to rhodonite, which is a manganese silicate, but they do look similar in many situations. Now, rhodochrosite is usually a lighter pink with white banding and reacts with acid. Of course, this depends heavily on whether or not it's completely crystallized or aggregated, but that's a little tip for you. Rhodonite, on the other hand, is generally harder, more opaque, and doesn't fizz in acid, largely because it's a silicate and rhodochrosite is a carbonate, so will react with things like dilute acid, like just normal household vinegar.